today we're going to talk this introduction to programming and specifically talking about Boolean logic. Now, Boolean, such a weird name, and that's how you pronounce it, is Boolean. I've heard a lot of people pronounce it Boolean, but that I looked up the definition and the pronunciation. It is actually Boolean, and it actually comes from, you see his picture, George Boole, who was an English mathematician back in you see 1865, in the 19th century, and he invented this Boolean logic. And so Boole's system uses operators that we're going to talk about, ands, ors, and nots, to really just show relationships between sets of data and to perform logical searches. And so Boolean logic is actually the basis of modern computer logic, and it's used on most online databases and specifically with search engines as well. So again, a Boolean search allows you to combine words and phrases using, again, those operators. We call them operators, and, or, not, right? They can limit, like filter what we get returned. They can widen it, give us back more information, and they just generally help us define, in our case, what I'm talking about now is like a search, right? And in fact, most internet search engines will default to using these Boolean search parameters. I don't know if seems like I'm always in Google trying to search. And when I do that, I always forget the fact that I can use the and, or, and not, okay? So as it says, right, we use this, when we write code, and so let's talk about code just a little bit. Well, but before we get to that, right, so we write programs to make them do things. We call them applications, and every code that we write has some kind of purpose, some job to fulfill. And so many times we want to be able to, so it says, map inputs in order to come up with an answer, or even to, as it says, determine what should we do next in our code. And Boolean centers around those three words, those three operators, and, or, and not. But in the end, these operators, combining these operators for Boolean logic, it's all about true or false. So, right, I'm trying to log into my bank. Does the bank let me enter? Only if I have supplied a valid username and the password matches, right? And that's that and right there, because I have to have both a correct password and a correct username and a correct password. And show the, hey, I'm on a website, and right, and the show subscribe pop-up. Well, if I'm a guest or I have exceeded my free limit, I've logged in and I have exceeded my free limit. But if I'm a guest, it's going to pop up and say, hey, you need to subscribe. Or if I've already created an account, but I've already used up all my free visits. So really, at the heart of Boolean logic is this on or off. And that always makes me think of a light bulb. But let's talk about a computer for just a moment. A computer is just a big electronic device with tons and tons of these little switches. You know, switches like the one hanging on the wall behind me. The light is on or the light is off. And so those are that's what's at the heart of a computer, this big electronic device with all these little switches in there. And all those switches are either on or off. And these little switches are called bits, as in B-I-T. So a bit is a switch that is, as I said, either on or off. And so one switch only gives me two values, like I said, either on or off. But if I have two switches in a row, one can be on and the other one can be off. One can be off and the second one can be on. They both can be off or they both can be on. So that's 4 different conditions. And as we continue to add, it goes up exponentially by the power of 2. So stop again. Let's think about computers. I always like to go back because I was a developer in the 90s. I like to say I had the advantage of being around, first of all, before computers were built. And then second of all, I got to see how all the programs were created. And I got to deal with some really old, clunky computers. I still have a computer that runs Windows 95. That's a story for another time. Who uses Windows 95? But anyway, so back in the mid 80s, when computers were just starting to become popular, people they would build computers in their garage. And I always like to say, Bill Gates, maybe you've heard of him. Steve Jobs, another kind of famous person. Maybe you've heard of him too. So, or even Steve Wozniak, who worked with Bill Gates, right? 2 friends. They were in high school building computers in their garages, and they wanted to create computers that did things. Well, we got to have the computers be able to speak the same language, because Bill Gates wants to say, hey, Steve Woz, they called him Woz. Hey, Woz, I've got this really great game called Pong. Right? This really great game Pong that I want you to be able to play. And so he'd give him something called a floppy disk. But if those 2 computers aren't speaking the same language, then it's not going to run. And so when I say language, I'm talking about the arrangement of these on and off switches. So a single switch is called a bit. It either has on or off. And we group together 8 of them. And 8 of them is called a byte, and that's B-Y-T-E. And maybe you've seen that, maybe you've heard of it before. But if I group together 8 of these on-off switches, or 8 of these bits, then I have 256 different combinations of ons or offs. And let's talk about it in computer terms. And we don't say on or off, but we say 1 or 0. Off being 0, 1 being on, okay? So 256 different combinations, so that when I'm writing my program, I'm Bill Gates, I look a lot like him. So when I'm writing that program and I want to give my program over to Steve Wozniak, I want the arrangements of those bits and those bytes to be the same on his computer as on mine. The arrangement that says that of the on and off switches, that this arrangement of on and off is for the character A, and this one is for the character B, and so on and so forth. And that's actually called ASCII. Oh, well, that's an acronym. There's so many acronyms. Come to Tech Elevator. You get to learn so many acronyms. But ASCII, A-S-C-I-I, stands for American Standard Code for Information Interchange. It's not really anything that you need to know, but I like to give you guys useless information all the time. All right, let's move on and talk about more specifically. So we talked a little bit about computers and the on-off switches, but now it kind of, I hope, makes a little bit more sense why computers are all about this Boolean logic. It's either true or false. It's either on or off. It's either 1 or 0. It's all those little switches. So when we talk about Boolean operators, right, we have, and I'm going to go through them, not, and or. And these are our 3 basic Boolean operators that we can combine together. And I just put up here what's known as it's called a truth table, but we'll kind of walk through it. And again, another piece of useless information that you don't really need to know. But notice that with the not, the The not is actually, in this case, notice it's an exclamation point. We call that a bang or an exclamation point, right? It just means give me the opposite. So you notice that if the value, we'll talk about things called variables. Variables are just places where we can store values. If the variable A is holding false, not A would be true. And if the variable A is holding true, not A would be false. So I like to think of, okay, the variable A is holding raining. So not A would mean it's not raining. When I put this together, it was raining. It's been raining a lot here in Michigan lately. So, and the same thing, let's think if the variable A is holding not raining, the opposite of that, or not raining, is raining. And I just did a double negative. And so you can see how the not operator can get a little confusing sometimes when we start writing code. All right, lost my mouse. There we go. And we're going to go through a little bit more in depth and or, because you can see they're a little bit more complicated than just the not. So we have the and we have the or. So let's take a look at and, okay? So this is going to, we use the and operator just to confirm or make sure two or more Boolean expressions, we'll talk about those in a moment, are true. So let's say here I am on a Sunday. I'm hungry too. So it's lunchtime, right? So, and what better thing to have than a sundae? But my sundae, I want my first flavor to be chocolate and my second flavor to be vanilla. And notice I can turn this into a Boolean expression here, right? I could, using that and operator, and even by using this truth table over here, we're saying A is flavor 1 and B is flavor 2. But notice, right? If flavor 1 is chocolate, because I said I want chocolate first, and flavor 2 is vanilla, then I'm going to eat my sundae. I'm pretty picky. But if you give me chocolate and strawberry, nope. If you give me mango and vanilla, nope. If you gave me mango and strawberry, the answer is no. And so thinking about the fact that with an and operator, both of my values have to be true, we'll go with, right? Flavor 1 has to be chocolate, and flavor 2 has to be vanilla. That's the only way an and expression will evaluate to true, okay? And so, and as I said, this over here, this is called that truth table. And a table like this is used all the time with Boolean logic. And we just put together, and that's why I've done these Sunday example, okay? Okay, so we've talked about and. Now let's take a look at or. So in an or expression, it just needs one of the conditions to be true. So this time I will only eat the sundae if strawberry is my first flavor or mango is my second flavor. Right? Okay. So again, taking a look on the slide, you could think of A as being holding strawberry and B is holding mango. But the only way this whole thing is the only way I get to eat this sundae is if my first flavor is strawberry or my second flavor is mango. Notice that if it's vanilla and raspberry, I'm not going to eat it, right? So again, following that truth tables, and isn't it interesting? I just have to back up just for a moment, that when we look at an and, 3 out of 4 are false, and the only way we get true is when we talk about sides of the and operator are true, versus the or, everything is true, except when both sides of the or operator are false, Okay. So I'm kind of just pointing that out. Is the and expression so strict that if you fed the table vanilla and chocolate is for the and? It is. Absolutely. If I, let me go back. Hold on a second. Let me just make sure. Yes, absolutely. Is it Zakai? Did I get it right? Or close enough? Cool. Yeah. So Zakai, absolutely. If I send it in the wrong order, because I am such a picky eater, I've got to have my chocolate first and my vanilla second. If you give me vanilla first and then chocolate, I'm not eating it. Okay? Okay, yeah. So that's a really great thing to point out. Absolutely. Okay, so hopefully you're feeling pretty confident. I'm going to give us a listing of those truth tables again. And then we're going to talk about a Boolean expression here. Again, a Boolean expression uses these Boolean operators and to evaluate back to a single Boolean value. And whenever you hear the word Boolean, think in your head true or false, true or false, true or false, true or false, because that's all that a Boolean value can be, is true or false, or as I already said, on or off, right? Okay, so here we go. Let's think about this. Here we have an expression, and notice it's combining ands and ors. Okay, a little complicated. So we have these ands and ors, and notice that wrapped around those ands are parentheses. The parentheses are there just like we used to have them. You have them in mathematical expressions just to clarify, and not necessarily to clarify for the computer, but many times I say we clarify for the developer who comes after us, right? We want to make sure that it is very clear what we want our code to look like. So let's take a look at this. And back in math, when you are given a mathematical expression, we start left to right, but perhaps you also remember, what is it? PEMDAS, please excuse my dear Aunt Sally. Maybe y'all are too young for that, but the order of expressions that happen in math. But we don't have to worry about that right now because we are just going to go left to right. So we have, and here it's saying, hey, the A is going to be true and B is going to be false. So what happens when we just plug in those values in place of A and B? We have true and false, or true and not false. Okay, so let's take a look at that. This back one here, what is the opposite of not false? It's true. Or if you're Margaret, you might say it's not false. But that's that double negative again. So that is true. So now we're evaluating this expression. And what is true and false? True and false. True and false gives us back false, right? How about true and true? True and true is going to give us back true, okay? So now we have false or true. False or true, and notice that means that the whole expression in the end evaluates to true. Okay. Hey, so you guys are doing great. You're learning so. We're doing wonderful. Okay, because now what is Margaret going to do? I'm going to throw in a couple more, and these are called comparison operators. So our logic operators for Boolean expressions are and, or, and not. Comparison, they compare two values, right? So look at the top one and you see that the operator, notice there's two equals there. And as it says here, the description is equal to. And when I'm in a session and I'm working with either students or alumni, I will always call it equal, just to drive home that there is a difference because a single equals does a different job. So double equals just says, hey, I want you to compare these two values. So again, let's think we're given, let's say we have a variable. Variable is just a place that holds a value, and the variable is called x, and it's going to hold 5. So what happens if we compare x is equal to 8? Is x equal to 8? Is 5 equal to 8? No, that is false. And sure enough. So this is one of the reasons I love computers. They're so logical, right? You just really, you have to get over a couple of the little quirks, such as everything has to be done in a particular order. But I love computers because they are so very logical. And so if we also have is x equal to 5, and notice how I keep saying that, is x equal to 5, right? Or x is equal to 5, is that true or false? Well, 5 is equal to 5, so we know that yields true, okay? All right, what about x not equal to 8? Is 5 not equal to 8? Right, that's true, because 5, or the value stored in x, is not equal to 8. How about x not equal to 5, 5 not equal to 5? Well, that one's going to be false, right? So it's very, very logical in how computers do things. And then we have our, I think of them as relational operators: greater than, less than, greater than or equal to, and less than or equal to. And we know by the fact that this variable x holds 5 that this is going to be false, this is going to be true, this is going to be false, and this is going to be true, right? So sure enough, there we go. We have, because 5 is not greater than 8, but 5 is less than 8. 5 is not even greater than or equal to 8, but 5 is definitely less than or equal to 8. Okay. Nice job. So now let's think about these things, right? So here we have two Boolean values. Boolean, true or false. So what you have on the screen here is, it's known as a function or a method or a module. It's just a little block of code that I've added to the screen here. And so in the parentheses, it says two Boolean values, two Boolean parameters. The first one is called has permit, and the second one is called with licensed passenger. So we want to write a Boolean expression that results in true if we can drive. We can drive if we have a permit and we are with a licensed passenger. Okay, so to me that means that has permit better hold the value of true, and with licensed passenger also better hold that value of true. And because they are Boolean variables, this is saying return the value of true and true, right? As long as those are true. How? Because if one of them, what happens if I don't have my permit? I cannot drive. What happens if I'm not with a licensed passenger? I cannot drive. What happens if I don't have my permit and I'm not with a licensed passenger? I can't drive. But if I have my permit and I have a licensed passenger with me, I can drive. Okay? So that's the and. All right, here we go. We're getting a little bit more fancy here, or complex. Okay? Can I drive? I still need what I had before. I have to have a permit, so this value has to be true. With licensed passenger has to be true. And our licensed passenger must be 30 or over. Oh, and this int right here stands for integer, which is a data type that holds numbers. Just means we're holding numbers. And in fact, we're holding whole numbers. Whole numbers are numbers that don't have that decimal point, right? So how am I going to put this together? Well, thinking about what we had before, I'm probably going to still have the has permit and use and, which on the last slide I forgot to point out was with the ampersand, right? So has permit and with licensed passenger, and passenger age greater than or equal to 30? Greater than or equal to 30 because it says you must be 30 or over. So if you're 30, that's good. I can still drive, right? Okay, I think I have one more. Dun, dun, dun. Okay, so can I drive? Everything from before. If I have my permit, if I'm with a licensed passenger, if our licensed passenger is 30 or over, unless they are our guardian, in which case age doesn't matter. This one's pretty complicated. So let's take a look and see what it says. So again, notice the use of parentheses around the last part to kind of help it make it a little bit more clear. In this case, it has to be there for the computer, but still permit has to be true, and we are with a licensed passenger, and the passenger age either has to be 30 or over, or the passenger has to be our guardian. Okay. So that's that Boolean stuff. Pretty cool. So let's go. Oops. Oh, I'm sorry. Ha, I forgot. There's one more, but yeah, there's one more. Hope maybe I think there's just one more. Okay. So you're only permitted to drive the hours of the day. So you can only drive with a guardian between, you're permitted to drive all hours of the day, but only with a guardian between 11 p.m. to 5 a.m. Oh my goodness. You see how complicated? We're taking that very basic Boolean logic. So we know everything has to be the same up to here, but then we are going to sit there and say, right? So if the passenger age is greater than 30 and the hour of day is after 5 a.m. but before 11 p.m., or the passenger is our guardian. So it's so cool how we start with that basic true, false, and we're only comparing two values, but we can string these together to make more complicated expressions. So let's take a look at, I'm going to drop in the chat here. I'm going to drop a link in the chat. And if you can, great, you can follow along. If you can't, that's fine, not a problem. But I'm going to come to this site because, again, it's talking about Boolean operators and logical operators. In JavaScript. JavaScript is a programming language. It's a programming language that we use when we are programming for the web. What is the web? Well, currently you are on the web. We are talking through Zoom on the web. So, right, so JavaScript lets us write code that can be run in a browser. So I'm running in a browser here, right? I have Google Chrome open. So I'm going to scroll down and notice, oh, hey, look, there's the is raining again. We've seen that before. Well, let me just make sure that I bump this up big enough for you. So notice it says is raining is my variable and it holds the value true. So if I run it, it's going to say I need to grab my umbrella, right? And then it's going to print out the value that is stored inside there. So what happens if I change this to false? Notice it says, no, I don't need to grab my umbrella, okay? Okay, so now let's take a look at, scroll down just a little bit further. There's our ands, ors, and nots. Let's take a look at this one. Okay, so we're asking ourselves the question, do I need a raincoat? Well, I need a raincoat if it is raining and it is cold. Do I need a sweatshirt? Can I just use a sweatshirt? If it is not raining, right? So if raining is false, but it's cold, then I'm going to grab a sweatshirt, unless you're my 3-year-old granddaughter who doesn't believe in wearing a raincoat or a sweatshirt, right? And then what do I need to do? I need an umbrella if it is raining or it is sunny, so I don't get sunburned, right? So thinking of these values here, is raining is true and is cold is true. So I know I'm going to need to grab my raincoat because that's a true and a true. Let me start at the top. I need to grab my umbrella. Umbrella means is raining or is sunny. So is raining is true, but is sunny is false. But because it's an or, I only need one side of those to be true in order for the whole thing to be true. So right now, my umbrella is going to, I need to grab it, will return true. My raincoat is raining is true and it is cold, so that's going to be true. And I need to grab my sweatshirt. Not is raining would mean that is raining needs to be false, but it's not. So it's going to return false for that last one. And what happens if I change is raining to false? What is going to happen here? So raincoat is going to return false. Umbrella is going to return false because both of them are false. And sweatshirt is going to return true. Yay! Okay. Hey, look at you guys are already pros at this. You got this, man. Look at this. Okay, so I'm going to scroll on down. Okay, here we go. This is our first our first challenge. So notice now, instead of giving us really nice variable names like is raining and is cold and, and is sunny, we're using variable names of A, B, C, and D. Those are really confusing, aren't they? All right. I'm teaching right now that we try to avoid using single variable, single letter variables because they're really confusing. What does A mean? I don't know. All right. So, but this is just because we're going to be taking a look at. So the expression A and B, well, A is true and B is false. So that's going to return. So we can, let's do this. True and false and true. And what is that going to give us back? Draw an arrow. Well, true and false, in an and expression, both sides have to be true. So this is going to end up being false. So when I just evaluate the first half, it's going to be false. And I end up with false and false. And so the whole thing will end up being false. Oh, okay. What about the second expression? Second expression says, and again, I find it easier to just fill in the values, false or true, or false. Okay, so let's do what's in the parentheses. False or true, as long as one side is true, the whole thing is true. So that's going to return true. And then we have or false. Or false. True, one side is true, so the whole expression returns true. Uh-oh, they're getting tricky on us now. They're saying, let's take that A or B, so let me do the parentheses, true or false, and true or false. So what do we get? True or false evaluates to true. True or false evaluates to true, so we end up with true and true, which evaluates to true. Okay. All right. The next one says not D. D is false. Not false, not D would be true, or B is false. And what happens there? We end up with true. Okay, The last one, the fifth answer. I always like to start with what's in the parentheses, but let me go ahead and do not true or, and do the parentheses. B is false or not true. So let's take the parentheses. False or not true would be false, the opposite. So false or false gives me false. So I'm going to have not true or false. What is not true but false or false? Anybody else confused? Right? So the whole thing evaluates to false. So our answer should be false, true, 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 false. Let's see how we did. False, true, 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 false. Woohoo! Nicely done. So hopefully you did well on that, just like we did together there. Hopefully it made sense. But here on this one, now it's giving us more, true and false, right? Let's use real terms. I said variables are named A, B, C, and D. They don't help out. They don't help you. Whereas here, okay, I'm going to go to the grocery store if I'm hungry or I need food and I have enough gas in the car. Thank you, Margot. Appreciate that. So how, right? I'm going to just open up a quick program here. So I'm going to go to the grocery store if I'm hungry, are hungry, or need food, and have enough gas. See how using these variables, are hungry, need food, has gas, really make it a little bit more readable, right? Your self-driving car will turn right if there are no people on the crosswalk and you have enough speed. So thinking about that, no peeps in crosswalk, and I'll use the ampersand, and going fast enough, right? In order to make cookies, you need to have white or brown sugar, eggs, flour, and I love this, and all ingredients need to be fresh with no mold. Okay. So I need to have white or brown sugar, white sugar, or brown sugar. And I like to think of those as being in parentheses, right? Because it's white or brown, but then I also have to have eggs. I also have to have flour and all the ingredients. So let's go all the way back up front here and say, and no mold, right? So thinking about all these, see if I can get that last parenthesis on there. And you decide to swim in the water if either the air or the water temperature is warm or you have a wetsuit available. I don't know. I'm only going in if the air and the water temperature is warm, but that's me. I'm a fair weather swimmer. So, all right. So hopefully that made sense. You understood the basics of Boolean logic. I'm going to stop that. I think that was it. This site. Oh, I see. We could have done this ourselves. I see now. I didn't even scroll down far enough to see that we could fill those in. I'm going to leave that for you to do. So that's it. There are lots more. I'm going to go back over here real quick and say thanks so much. We have time. I never finish early, so I have lots of time. So I'm going to take any questions that you might have about, first of all, let's talk about Boolean logic, but also know that this is one of the basics that you need to know for programming, is that whole how we call them expressions. How is this going to be evaluated? How is the computer going to evaluate this line of code, this sentence, shall we say? And that's what happens with Boolean logic. And then we add on to that Boolean logic, because with computers, we also have the ability to do what's known as repeating code or looping code. And so all programming languages give you the ability to have Boolean logic, using ands and ors, and what we call conditional statements, which is using the word if. So if I'm hungry or I need food, I'm going to go to the grocery store, right? Using those ands and ors. And then I have that ability to loop through the code, right? I can repeat that every single day. Am I hungry or I need food? Then I'm going to go to the grocery store. How about tomorrow? Well, if I'm hungry or I need food, I'm going to go to the grocery store. And those are the basics of a programming logic. All right. Enough about, as I said, about the whole Boolean. You're a good group. I hope it was fun.